Good evening to everyone. I'm Ario Fahimi, a PhD student from the University of Brescia in Italy. I'm here to present a novel material for the absorption of emerging pharmaceutical micropollutants. And why the emerging pharmaceutical micropollutants? This is a specific category concerning non-steroidal anti-inflammatory drugs such as diclofenac. And these pollutants have the particular behavior in their life cycle to be accumulated in surface water after their treatment in the wastewater treatment plant. And their concentration in this surface water are quantified in terms of microgram per liter, and this is the reason why they're defined as micropollutants. And on the other hand, they're called emerging because the norms and the legislations regarding this category of pollutants are lacking for example, in the European framework and also in other continent framework. So the problem basically relies on the inefficiency of the conventional wastewater treatment plant for dealing with this kind of pollution. And this is because of this low degradation behavior of these pollutants during the steps of this process for their scarce volatility. So the attentions goes to the step which is more well studied in literature, that is the advanced filtration systems. And among them, the physiochemical process, that is a combination of a physical and chemical interaction between the solution of the pollutant with water in this case, and the adsorbent material, which is aimed for the absorption of this pollutant. And this technology, this technique is very well described, very well exploited with different kind of materials, with excellent performance. But the problem is that the absorbent material at the state of the art have the problem to face regeneration, that it is very costly in terms of expense. And so we have come up with proposing a new material, eco material, based on the combination of waste material deriving from byproduct of industrial processes, such as incinerated municipal solid waste, in combination with the fly ash residue of the coal combustion. And in addition, from the same process, we can use the flue gas, the sulfurization of the coal fly ash, and that are the residue from the desulfurization, and also the residue, the byproduct from the smelting of iron, silicon, steel smelter. And these are combined with water, in particular the double distilled water, the ultra pure molecule water, as much as it is necessary to get a semi-solid compound. And the mechanism is based on the diffusion of the solute, that is our pollutant, within the interface that is set up, that is established between the solution and the sorbent material. And after this diffusion, the solute goes towards the absorption site of the absorbent material. And and until we can get a uniform layer built up of adsorbate of solute on the material, on the adsorbent material. Before doing the experiment, in order to make it qualifiable and also reasonable in this kind of application, we have to characterize the material. In this case, we can see the crystalline characterization of the material done with the X-ray diffraction technique. And you can see several different peaks for different angles that are characteristic of a specific crystal. And you can see that these materials characterized by silicon materials such as quartz and cristobalite, and also the gypsum that is used in civil application, and calcite that is calcium carbonate. And the kinetic study of the experiment shows that if we compare in the ordinate, you can see the concentration of pollutants in the solution with the increasing of time. This concentration tends to decrease, and this decrease it tends to be slower by time, and it reaches a plateau that is defines the equilibrium stage of our kinetic study, our kinetic behavior of the material. And in the same time, you can see by increasing the concentration of the adsorbent material from 10 grams per liter to 50 grams, for example, per liter, this decrease is much higher per the same time. And comparing the performance of our material with the state-of-the-art adsorbent material for excellence, that is the activated carbon, we can notice that is very, very comparable at first experiment, and we can say that our material is formed, is synthesized with a really, really simple formula, so that is directly correlated to the regeneration that is very, very simple to get. Again, this material after multiple times doing its task with respect to the activated carbon that has the problem of the cost of the regeneration. And again, in the equilibrium stage, we can see also the experimental experimental data points that are well modeled by mathematical models. In this case, the Langmuir isotherm. And this is explained making the relation with the QE that is expressed by the amount of pollutant absorbed by the adsorbent material per gram of the adsorbent material in relation with the concentration of the solution at equilibrium. And you can see under the literature classification, it is a first order classification with the Langmuir approximation. And finally, we have done also sustainability evaluation that compare our material with the activated carbon in the frame of all material that are shown in this graph that is elaborated by the Cambridge Engineering Selector software. And we put in relation the embodied energy, that is the energy involved in every steps for the formation of the material at primary production, in relation to the price of this material, price to get to the formation of this material. And they are both normalized with respect to the kilogram of material. And you can see that Cosmos is more sustainable relatively to the other material, especially to the direct comparing material that is activated carbon. In the same way, we have the same graphical pattern for the carbon footprint evaluation, that is the quantification of the greenhouse gases emissions related to the formation of the material at the primary production of the material. In relation to the price of the material, and you can see in the same way that Cosmos is relatively more sustainable with the activated carbon and with respect to the other material present in the database of this software. So in conclusion, we've seen that a novel material has been characterized and proposed as a substitute material for substitution for adsorption application in wastewater treatment plants, and the kinetics shows the behavior of the material is tend to reaching the equilibrium after 2 hours with respect to the adsorption of our experiment. We refer to the diclofenac drug, and then the isotherm was elaborated and followed the Langmuir approximation model and sustainability evaluation about the primary co-production of Cosmos showed that it is more sustainable with respect to the activated carbon, and also in terms of carbon footprint. And you can see in terms of value, they differ by 1 order of magnitude. And I would like to acknowledge my professor, Elsa Bontempi, my supervisor professor of my PhD project, and all the chemistry for technology and laboratory staff of the University of Bruges. For further information, you can reach me via email address and also the ResearchGate platform. And these are contributions that have been published, and I exhort you to give a look at this work and support our work with your question and observation. Thank you for your attention.